Dear students, I am Dr. Ravind Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamani Devi Group of Institution Indore. I want to teach you through lecture 2, solution of linear and non-linear differential equation of order 1 and degree 1. So first of all, we understand what do you mean by an differential equation is said to be linear. A differential equation is said to be linear if the dependent variable and its derivatives appear only in first degree and are not multiplied together. That is, the equation of the type dy by dx plus p of y equal to q is called linear differential equation in dependent variable y, where p and q be some function of independent variable x. Let me introduce ourselves by using how will you solve this category of differential equation, that is what is the methodology. Let me understand. So in such case, let me assume that the complete general solution of given problem is dependent variable y equal to u into v, where u and v some function of independent variable x. So now differentiate both the side with respect to x. So left side differentiation is dy by dx equal to first function u as it is into differential of second function plus for second function as it is into differential of first function. So therefore, on putting this value in the given equation, because it is a solution of this, so this gives to you u dy by dx equal to u dv by dx plus v du by dx plus p of uv equal to q. Or we can write the given equation into this pattern as du by dx plus p of u of v plus u into dv by dx equal to q. So in equation number 2, one of the two function u and b is arbitrary. Let me choose that, or let me assume that u to be arbitrary is in such a way that this factor must be 0. Du by dx plus p of u is equal to 0. That is, now we write as du by dx equal to minus pd of x, because p is function of x. So now therefore it is in variable several form. Therefore on integrating both the side, you will get left side integration is log of u equal to minus of integral of p dx. By taking anti-log, you will get the value of the arbitrary function as u equal to e raised to minus p dx. Hence the equation 2 becomes, on putting this value, this substitution in equation number 3, it gives to you as u dv by dx equal to q, that is dv by dx equal to q upon u, or we can write as dv by dx equal to q into e raised to p dx. Substitution the value of u, or we can write as dv equal to this. Again you are getting q is a function of independent variable x, and this is also a function of x. Left side is only function of v, that is it is in variable several form. Therefore integrating on the both side. So this gives to you as the solution of this equation is v equal to integral of q into e raised to p dx of dx plus c. Hence the required general solution is obtained by equation number 2 is, on putting the value of u and v in equation number 2, you will get this is the general formula of finding general solution of linear differential equation. Or we can write this expression which is to be commonly used in this pattern: y into e raised to integral of p dx into integral of q dx p dx e raised to dx plus c. So this factor is denoted by or be called as integrating factors. E raised to integral of p dx. Let me come to an example on this topic of how can you apply this method for solving problems. So first of all, given equation can be written as by making the coefficient of first order derivative to unity, and therefore on comparing with our standard forms dy by dx plus p of y equal to q, it is linear in y. Therefore on comparing with this standard form, this equation, you will get capital P as CSIR x, that is the coefficient of dependent variable y, and q as terms having function of independent variable on the right hand side of given equation as CSIR x 10x. So therefore now you will find integrating factor as e raised to integral of p dx, that is integral of CSIR x dx, that is CSIR x integration is 10x, so e raised to 10x. Therefore on this basis you can write the general solution by using the above formula, that is y e raised to 10x integral of CSIR x 10x into e raised to 10x dx. Now how can you solve these integrals? Because here the differential of 10x is available, 10x ka differential is CSIR x, so that's why in order to solve this type of problem, put 10x equal to t. Therefore on differentiating you will get 10x ka differential is CSIR x dx equal to dt. Hence the above equation becomes, by putting this value is y e raised to 10x integral of t e raised to t dt. Then you know that how will you solve this type of integration having different function in product form. You are applying the integration by parts formula. This gives to you y e raised to 10x equal to first function as it is integral of second function is e raised to t minus differential of first function is 1 into integral of second function e raised to t, then again integrating you will get a minus of e raised to t. Or you can now you write this equation general solution in our desired form by putting t equal to 10x. So this is your desired solution of given problems as linear differential equation. Now we come to the one more example of this same pattern here. So this is the differential equation of first order and first degree, because you cannot separate the variable forms, and so that easy to solve by reducible to linear forms. So this type of equation can be written as into linear form as this is not to be written linear in y. That's why in such case you try to write linear in other variables. That's why I write the given equation linear in x. So y log of y dx upon dy plus x minus log y equal to 0. So that is on dividing this whole equation by this factor, it gives to you dx upon dy plus x upon y log of y equal to 1 upon y. y log y से डिवाइड करेंगे तो आपको दिस इक्वेशन यू विल गेट इट दिस इज लीनियर इन x. सो देयरफॉर यू विल फाइंड द इंटीग्रेटिंग फैक्टर्स इंटीग्रेशन ऑफ 1 upon y log of y dy, because in this integral differential of log y is available. That's why you are putting log y equal to t. So then integral of e raised to 1 by t of dt, 1 by t का इंटीग्रेशन होगा log of t, that is by taking this log of base and the base of this is same, so the answer is t. T means log of y. Hence the general solution of given problem is dependent variable x in which the equation is linear. So multiply by integrating factor, then integration of integrating factor into multiply by q of dy plus c. So tell me the answer of this left side, x log y equal to of this integrating factor log y upon y of dy. Now for solving this integral, put log y equal to t, then substituting this you will get t dt. So what is the integral of t dt? As t square upon 2 of plus some constant of integration is c. So what is the value of t? Is log y whole square upon 2 plus c. So this is the desired answer of your linear differential equation, where c is the constant of integration. Let we come, how can you solve the nonlinear differential equation of first order and first degree? So this type of problem we also call, it is called by Bernoulli's, so that's why it is also called a Bernoulli's equation. So the equation of the type in one variable, say dy by dx plus p of y equal to q of y raised to n, is called a nonlinear differential equation in y, or Bernoulli's equation or Leibniz linear equation, where p and q be some function of n of x when n is greater than 1. For Bernoulli's equation, always n is greater than 1. Let me see how can you solve this type of equation. Very simple technique. Our objective is to reduce into linear forms. So whatever may be the multiple factor of function of dependent variable is available, you divide the whole equation by this factor as y raised to n. So this gives to you y raised to minus n of dy by dx plus p of y raised to 1 minus n equal to q. And now to solve or to convert completely into linear forms, you are putting change of variable techniques. So you put this y raised to 1 minus n equal to t. That's why on differentiating with respect to x on the both side, this gives to you 1 minus n of y raised to minus n of dy by dx equal to dt by dx, or we may write into desired form as y raised to minus n equal to dy by dx equal to 1 upon 1 minus s by adjusting minus sign here, and dt by dx. If it is possible by you, or you will write as it is 1 minus n upon 1 upon n dt by dx. And on putting this in the previous one, equation number 2, it gives to you in this pattern here. Or we can write as dt by dx by making the coefficient to 1 minus n of p of t equal to 1 minus n of q. So this is the linear equation in t. We can solve accordingly as we know the method, by first finding integrating factors and then writing the general solution is t into dependent variable whatever may be the linear integrating factor, integration of integrating factor 1 minus n of q of dx plus c. So that is, this is the general formula you can say, or you may directly solve the equation by using these techniques, where c is the constant of integration. Let me come to an example on this topic. As suppose this is a problem, x dy by dx plus y equal to x cube y cube y raised to 6. Clearly this equation is not linear in x as well as not linear in y, so that's why here it is in the pattern as dependent variable having right hand side power is greater than 1. That is, the equation is in Bernoulli's type, that is non-linear equation. That's why you divide this whole equation, because our objective is to make first dy by dx coefficient to 1. So that's why we divide this whole equation not only by x, and also we have to eliminate y raised to 6. So that's why we divide this whole equation by x y raised to 6. So this gives to you y raised to minus 6 of dy by dx plus 1 upon x y raised to minus 5 equal to x square. Now what is our strategy of solving this equation? By putting this factor as equal to t, and then on differentiating both the side with respect to x, this gives to you minus 5 y of y raised to minus 6 of dy by dx equal to dt by dx. Hence, by putting this value, the equation number 2 becomes minus 1 by 5 of dt by dx plus t upon x equal to x square. Or you write in the linear form as dt by dx minus 5t by x equal to minus 5x square. It is linear in t. Therefore, first you will find integrating factors. P is minus 5 by x. So minus 5 by x, integration of minus 5 by x is log of minus 5 log of x, सो x की पावर आप लोग लॉग के अंदर बेस में शिफ्ट कर देंगे. सो दिस गिव्स टू इंटीग्रेटिंग फैक्टर इज x raised to minus 5. Therefore, you write the general solution as t into a negative factor I into f of 1 minus n of q of dx plus c t of x raised to minus 5 into of x raised to minus 5. Now, by combining these powers, you will get this in the next step as minus 5 x raised to minus 3 of dx. So now please integrating this x raised to cube minus cube. क्या होगा इसका इंटीग्रेशन? माइनस 2 अपॉन डिवाइड बाय माइनस 2. सो माइनस माइनस प्लस हो जाएगा आपका. सो दिस गिव्स टू यू जनरल सोल्यूशन इज y ऑफ t की वैल्यू वी आर ऑल्सो सब्स्टिट्यूटिंग x raised to minus 5 y by 2 x raised to minus 2 plus c, where c is the constant of integration. Thank you very much.